Having completed a single tuned and double tuned amplifier, the third type is going to be stagger tuned amplifier. So we have seen the comparison of single tuned and double tuned yesterday. So when you compare single tuned amplifier and double tuned amplifier is going to provide more bandwidth when compared to single tuned amplifier. One drawback is the circuit is going to be bulky because I am going to use transformer. Okay, so one more type of amplifier is a stagger tuned amplifier. So we will see why stagger tuned amplifiers are designed for our circuits. So as I said, when the bandwidth is the major constraint for you in real-time application, so in order to increase your bandwidth, you may consider going for double tuned amplifier, but alignment, or I can say the circuit design of double tuned amplifier will make it difficult for implementation, because for transformers we don't have a simplified circuit. It has to be connected externally to the double tuned amplifier. Other things, capacitors, other the transistor and all, we can make it as a very small microchip, but transformer alone cannot be simplified. So that makes the usage of double tuned amplifiers even more difficult and inconvenient. For that case, if you want to increase the bandwidth without disturbing the circuit, or without my circuit causing any problem, I can go for a stagger tuned amplifier. The stagger tuned amplifier is going to be cascading of two single tuned amplifiers, but the difference is both the single tuned amplifiers are tuned to slightly different frequencies. So we have seen previously, when you have single tuned amplifiers in cascade, both the single tuned section will be tuned to the same frequency F0, right? But the stagger tuned is completely different from that. You are going to have two single tuned amplifiers in cascade, but the only difference is both the tuned amplifiers are tuned to a slightly different frequency away from F0. So if the first stage is going to have frequency F01, second stage will have a frequency F02. And F0 will be in between F01 and F02. So if I'm going to connect these two amplifiers like that, that is going to be stagger tuned amplifiers. So see here, the resonant frequencies of the two tuned circuits are affected so that they are separated by an amount equal to bandwidth of each stage. So when you find the difference between the two resonant frequencies of the two stages, it will be exactly equal to the bandwidth. So since the resonant frequencies are displaced, or it is changed, or it is staggered, it is called a stagger tuned amplifier. So you know the first stage is going to have frequency F01, second stage is going to have frequency F02, right? So it is not same frequency F0 everywhere. The two frequencies are going to differ from the resonant frequency F0. So since the displacement is going to take place, these circuits are called as stagger tuned circuits. Okay, remember, stagger tuned means it is the single tuned circuit only. I am going to use two single tuned circuits in cascade. The difference is the two single tuned circuits are tuned to two different frequencies which are slightly away from each other. So when you see the frequency response graph, you will be able to understand how the response is going to be for stagger tuned amplifier. So see here. So I have three graphs here. You see the first graph is the response of tuned circuit 1. It is going to have a peak at F01. So this peak frequency corresponds to F01. The last graph corresponds to tuned circuit 2, which is going to peak at F02. Individually, if you draw the frequency response, this is going to be the thing. But when you make them cascade, the frequency response will be coming. The middle one is going to be the frequency response of stagger tuned